Welcome to my presentation. I will start this presentation with inspecting and cleaning data. As a part of my assignments, I've been provided the data sets of Marks and Spencers, which that has 9 stores sales details and their corresponding departments as well. So initially, I just quickly skimmed through my provided data. Then in here, I didn't find anything to my naked eye. Any visual errors. So in order to do it systematically inspecting, I just I did bold the top row labels and freeze the top row as well using view buttons and freeze pan. Then I soon after the freezing the top row, I use the filter options to filter the table. So this basically provides me provide me an idea like is there any blank here, whether this is a can this be categorical, or whether this is other informations, or like uh, uh, so you can basically think what sort of a data this could be by using and also it can be in the field option can help you to organize your data, largest to small, smallest to largest, sort by colors. In the few when it as you work alone, it will help you to do some analysis with field option. So it is important to have uh, filter options here at the initial stage. Then is the data complete? So when you have a filter, the best thing of filter that you can simply find out whether there's a blank in here. If there's a blank, it will pop up in the filter button. There's a blank here. So it as far as filter says that there's no blank, so I can confirm that there's no blank. So the next is the data valid. So in order to validate the data, so we have many options. One is that go to data tab and validate the data if you have any data range, but in this case you have not been provided any data range to validate. So as a part of my learning process, I can use conditional formatting as well. So in the conditional formatting, I use color scale to the uh, sales column, but as you can see, as I applied, there's no sense in that, just uh, all yellow and green. Anyway, the darker the green is, the higher the number, and the darker the red is, the lower the number. Then if not, what we can do, I will keep it for the next to come in. So I'll go to the duplicate removers. So in the table itself, I can use the duplication. I can use the duplicate removal options, where it is located in data options and data tool. So basically, this is this highlights. Once you use the option, it highlights the entire table, and you can use it. You know that all the columns are clicked, including the header. So you can see that there's no duplicates anyway. So only thing while inspecting data that I find, which I cannot show here, and I have taken some screenshot of here, that departments, under department I seen that the homeware being spelled incorrectly. So I replaced that one with with that one with find an option, replace buttons, and homeware I replace with homeware, the proper homeware. So, and apart from that, when I see the details of the sales, uh, I see that some outliers as well. This is just to mention here. I will go back to inspecting and cleaning data. So I look some strange fingers in the sales. So I wanted to validate that one. When I have the outliers, I assume that I will contact the data provider and will check whether they are outliers or real outliers or type error. I will get the confirmation to remove that the outliers. So in order to remove the outliers, what I did, I I in order to remove the outliers, I summarize those data using the uh, data analysis option. Basically, what I did, based on the department and based on their stores, I summarize the data, including the outliers. So initial stage, I include the outliers. Then it shows me the mean, that 188,000 and 953, and where the median is 88,000. You can see that maximum number is 9,240. So there's a huge difference between mean and the maximum number, which cannot be. So after that, I remove the outlier, which I noted here. So soon after that, remove after the removal of outlier, I again summarize the data provided under particular department and under particular stores using data scriptive. So this is how I use it. I use the input range, the input range of the sales, and then the column. So I include the label as well. The it asks me where the output range we need. I choose it and summarize statics. Then these are the outcomes that I got. So let me show you one example. So this is promotional. This is clothing and footwear in Inverness store. So when I filter that one, I see that the 83 is the lowest number, which is not in the frequency of these fingers. So I thought I assume that this could be outlier. So I thought to replace that one. So you can show you that what done here. So without removing the outliers, I see that minimum is 83, where the mean is 10,667. Then I remove the outliers and get the average and apply those average to the sales column. Then I run the data analysis and descriptive statics. Then I got these fingers. So once I got these fingers, number being replaced, this number being uh, replaced in the area of outlier. So I have shown in here. So now I believe that my data is already good to go with the future decisions and future analysis purpose. So next one, according to my assignment, is dashboard. So I create the dashboard. This is my dashboard. So the first chart is total revenue, and the second chart is avenue average sales of revenue. So most of the you can see that most of my chart based on the average. So the reason why I got average, it is good comparison. If you get the straight away the data, like the sales of here, total sales, you can't compare with any other situations. You don't know what is the average of that. So it is good uh, uh, measurement tool to use the data. Let me show you that how I did the pivot table, the preparation of dashboard. This is initially that I uh, took the total sales of here based on their stores, and this is the total revenue stores. And the second one is I did not include. This is because it did not give me any sense, that I thought that it would not be good enough to include in data sets. The second one, I sales revenue included it sales revenue of stores and their respective department based on the each square feet. In here, I try to get the I try to see how good they are using their spaces. If you take Aberdeen, they use in their clothing footwear, they earn about 46 every square feet. So this basically provides how much money you can each earn in each square feet. The next one is average sale of the department. So we have three departments. We will get average shares of them. And and next one is the average sales of non-promotional and promotional items. So they all reflect in the dashboard. I can explain it very well. So as I told you in the initial stage, this is the sales of total sales of these stores. So it is being organized based on the highest amount. So this is 2,238,000, and the next is Edinburgh, and it is 1,559,000. So this is how it is organized. This is the total sale of for the first quarter in the Marks and Spencers, and the second one is average sales of revenue of stores. This is the average of the first quarter. So now you can see that the March is the highest. March sales are quite high compared to the January and February. So this is a very good indication to see that where your sales are in each month. So as soon as you see this line chart, you can see that the March sales are going up, and you can see the trends. Even still the trends of the the stores are the same though, but the sales are increasing every month. uh, the next one is average sales by department. So this shows the average sales. This is clothing, food, clothing and footwear. These are the average sales. The average sales in the sense the sales of the total sales divided by uh, number of days, number of transactions. So you get average sales here. So let me show you that. Apart from that, this is I have used the slices to check each stores. So in here, you can see that average sales of department based on the promotional and non-promotional products. You can see that clothing and footwear, the the orange indicates a promotional, blue indicates a non-promotional product. If you, as long as you have promotional products, the sales are quite high compared to compared to the non-promotional item. And the food also, you can see that there's no different whether you have promotional or non-promotional. The This will go, this stay a bit higher than the uh, non-promotional. And you see that homeware, the when you have promotional, the sales are quite high. So you can see that straight away. As far as you have promotional products, the sales are going up. So it can be change that you can see that when you have promotional, it's high. When you see that food is not depend on the sales, I mean the promotional or non-promotional, anyway it stay in the same way. The homeware also varies with the non-promotional items, so the sales goes up when you have uh, promotions. So sales revenue again, as I explained you, this chart shows you how good you are utilizing your space. Let's, for example, so Aberdeen, each square feet during, in the limit of 1 square feet, they earn about 46. So the best stores that utilize their um, square feet space based on the square feet, that is Galasco, because they earn about 72 pounds for each square feet. uh, this is my dashboard. To In order to make it activate, I use that options. I use the analyze options and insert slices. I could use the insert timeline, but I seen that there's no sense sometimes. As long as if I get the quarter based thing, if I need it, I can use that one as well. So the next question is risk analyze. Uh, so basically, the question asked me about utilize the Monte Carlo simulation to perform risk analysis of profitability levels to analyze to see the profitability levels of when you have margins of 60 and 70 of revenue sales. So is they said Aberdeen stores Aberdeen should be the one to be used, and homeware. So you can see that in the first quarter you have sales like different sales. They have about 59 yeah, 59 sales count in the Aberdeen stores in homeware. So what I did I create in order to see the profitability or the probability of loss of making when you have profit margin 60 to 70. I create a profit model. So it's basically with the daily sale. It says that daily sales, the profit margin is from the daily sale. So you can get the daily sale from uh, your sales column, and overhead cost is 4,250. Profit margin is I have used it's 60% right now. Our net profit is the daily sale minus uh, daily sale minus daily sale is the daily sale uh, into 6. Let's say profit margin. You have to add the daily sale at the profit margin, then minus the cost of overhead cost. So anyway, to daily sale is unpredictable and variable. So what I did, I use a random between. I used the VLOOKUP option to get the daily sale here because basically I rely on the historical data. So I add a column here, uh, add an external column number of transactions, number of transaction. So I can see that daily sales that goes like 59. So in here I choose a random number, so 1 to 59, which it will apply to daily sale. So to get the daily sale of random number, I use VLOOKUP, where it will look at this value and bring it to the daily sale, and it will cross check with profit margin here to see what is the net profit. So after that, what I did, I just run the profit simulation of to understand how many chances that we can earn, what is the possibility of earning profit and loss of 400 times. So I run only 400 times. So you can see that the numbers marked in red are the loss numbers making marking numbers are marked with green the profit. So in this case, profit simulations I used the data analysis and sorry, it's and to table, go to table and insert input cell, go to input cell and choose another column to get these fingers. So once I got the simulations for each cases, uh, then I got the average of making profit here, and median of making profit here, standard deviation, and maximum profit here. You can see that minimum profit here as well. uh, in this case, after that, just to make it visualize, what I did, I arrange bin ranges to see how many profit. less than 800, lost, and the other one is from minus 800 to minus 400. How many chances that we can have the frequency of having minus 800 to minus 400. The next one is from minus 400 to 0, so the frequencies are here, and the other one is from 0 to 400, which is a profit. So then the other one is 400 to 800, the chances of making profit. So basically, what I have to say here, the profit and loss, profitability of loss here is 43% in the case of 60. When you put profit margin onto daily sales, it is not good profit margin. I mean, the chances are almost 50% to make your business lost. So I changed this to 65% initially, and see what changes it can. So, it brings me the profitability. The level is under the 10, under 10, to be more precise, it comes to 7. So it means the more I will check with 70% margin, because I can vary that one from 60 to 70. And see the number, if you go to the 70% margin, the profitability loss makes only 5%. So it clearly visualize here that the chances of having, you have the 44% of making the business profit from 400 to 800, 176 chances, and 44% out of the 400. So making profit from 0 to 400, you have 42 chances and 11%. Basically, this is the analyze part in my presentation. Then let me go to the optimization level. So when it comes to optimization, they want us to optimization process to minimize the transportation cost of food. They want to minimize the transportation cost of food and each stores, and there's distribution hubs. The data is provided with their distribution hub, their cost from each hubs to the stores. So this point 6 is, you can say that 0.06 is, so every pound they spend, they have to spend 0.06 pence, in pounds, for every stores here. So then, in order to minimize the transportation cost, I have to initially see the sum product, that is, if view, uh, you have to multiply the cost, the real cost, with the cost of the transportations. So then you're going to minimize that as much as possible. So you are looking for a least possibility of spending money when you are using the transportation hub. So to get the minimize the to get the minimize to minimize the process, we will check, we will use the sum product uh, some product formula to that. Then you will use the solver options here, solver options. So in this set, you have to set the objective. Your objective is to minimize the number, so you will use it here. Then the changing variables are the variables that you can change, these are the area where you can change. You have given some capacities. These are the capacities which every hubs carry, so you can't exceed these capacities. So they are the constraints, and apart from that, the company has to deliver, their requirement is to deliver this much of this much of amounts of goods uh, to these stores. So it is being clearly mentioned here. Uh, the distribution center must be able to deliver at least the equivalent of maximum number of promotional day sales. So they it's basically asks us to take the non-promotional maximum number. So I take the maximum number of uh, uh, daily sale of non-promotional item. Then this is the equation. So I got so so then when I run the simulations with the constraints, when I run the simulation with the constraints, I get these values where you can uh, use is Kilbride and Galascon 97,220. So this is the hub that can be used for the Galasco. These are the other hubs that you can use for each on their corresponding stores. So basically, mm, uh, it does not. You can see that the optimization process do not exceed the capacities of the hubs. So it is minimized. It has minimized the. This is the best optimization of these uh, uh, for this process. Uh, as of now, that's all my presentation. Uh, Thank you very much.